isn't, and I didn't really realize this, I've always taught it, isn't tested on the AP test. You can use it if you see it. But they're not going to specifically say, hey, use the root test on this, or like multiple choice wouldn't come up with, hey, they like converges, excuse me, by the root test. So we're going to look at it. I'm only going to do a couple problems. I think I threw a couple in the homework just for good measure. But again, it's a nice to know one, not a need to know. So that eliminates, there's two or three of them that we put on the, like that one you don't really need on your orange sheet because we're not going to see it on the AP test. So the way that this one works is we've got A sub n is a series. It converges what we call absolutely, and we'll get into absolute and conditional in the next lesson. So we'll see that probably on Wednesday. So we'll understand what that means a little bit more after that lesson. It converges absolutely if we take the limit as n approaches infinity of the nth root of the absolute value of a sub n, and that's less than 1, we know it converges absolutely. Okay. If that function is greater than 1 or it equals infinity, then it diverges. All right. If it's equal to 1 and they didn't list this on there, it's inconclusive. Oh, you know what? It somehow got cut off. I'm looking at it on my other sheet. It somehow got cut off. If it equals 1, it's inconclusive. Did I do that on the other one too? I can't remember. Somehow I missed the inconclusive on it. All right, let's take a look at example 2 here. Okay, so we're supposed to determine the convergence or divergence of the series. I am going to rewrite this one a little bit. So I want it to look a little bit more like that power of n. These are really good when we have powers of n to use it for the n to use the root test. So because you're going to take the nth root, so it would cancel the power of n out. So we get e squared over n all to the n power. It's the same thing, right? We're just taking that exponent and kind of undistributing it. All right, so now I'm going to apply the root test, which says that we're going to have the limit as n approaches infinity of the nth root of the absolute value of e to the 2n over n to the nth power. Okay. Well, what's going to happen with the nth root and the n? What do you guys think? What happens with the nth root and the n? They're going to cancel. That's right. They're going to cancel. All right, so that means then that I'm really looking at the limit as n approaches infinity of e squared over n. That's not so bad. So, when I take the absolute value of it, it's going to be positive. That's why I dropped it. So we've got e squared over infinity. What's the limit as e squared goes to or over infinity equal to? Because e squared is going to be 2.718 times 2.718. What do you guys think? Nate says 0. What does everybody else think? Yep, all kinds of 0, right? All right, so that one's equal to 0, which is less than 1, which means we are going to converge absolutely. So then we would say, therefore, converges absolutely. That's an S, absolutely. I can't spell today. Let me just try that again. Absolutely by the root test. It doesn't hurt for you to write down which test you are doing, okay? On the AP test, and sometimes on multiple choice, they say, hey, it converges by this test, it diverges by this test, it converges, so you want to make sure you're understanding which test, to analyze which test you are doing, okay? Now we're going to try one more root test. This one's nice because look at what it is. It's to the nth power. So that's a big giveaway that, hey, you want to use the root test on it, okay? So I don't have any manipulation to do. I'm just going to put it right into the root test. So I've got the limit as n approaches infinity of the nth root of n squared plus 1 over 2n squared plus 1 all to the n power. And woohoo, what happens with the n and the nth root again, guys? What happens with the n and the nth root? Oh, they're going to cancel. Nice. Okay, so we've got the limit as n approaches infinity of n squared plus 1 over 2n squared plus 1. All right, okay, I'm going to ask, I just want to see where we're at on this. What's the limit? Tell me what you think the limit is. I've got one answer. Casey says she knows. Okay, so Josue, can you explain about the powers to me a little bit more? What about the powers makes you say that it's 1/2? Oh, the exponents are the same, so we just take you just take the coefficients. Good job. Okay. If you don't remember that, could I have used L'Hopital's rule? Okay. It doesn't matter. Spelling doesn't count in this class, right? That's why it's the best class ever, right? No spelling errors do I mark down for, because I can't spell either. So we have the powers are the same, so we take the limit of the coefficient, so it's equal to 1/2. I could have also gone through the L'Hopital's rule a couple of times, and I would have reduced to 1/2 as well. Okay, so when I am equal to 1/2, I am still less than 1. So this was another example of it converging absolutely. So we would say, therefore, it converges absolutely by the root test. Okay. The next piece. Did you guys also notice and I did put this, if you went and picked up the notes, let me get into Google Classroom. This is not your Google Classroom. Okay. In the note, or in your notes pickup, hopefully you noticed, let's see if I think I posted it in last week somewhere. This guy here, this series test flowchart. So it's another tool. You can use it on the test for the unit. Obviously, we can't use this on the AP test, but we can at least use it for the test for the unit. So you can use this. You can use your orange sheet. It's kind of like a flowchart of, hey, what should I be looking for? So the first thing I'm going to test on most of them is I'm going to see if it equals 0. If it doesn't equal 0, then I know that it diverges. Okay, right? Then I'm going to ask if it does equal 0, then I'm going to try to see if it's a p-series or a geometric or an alternating, and then again the conditions are there. Okay, probably not going to see any telescoping. It's not tested, so I probably won't. We probably can skip that one. We're not worried about Taylor right now. That's coming. So then we have the comparison test. That's the BCSD, and the limit comparison test. And again, you kind of follow the branches, all right? And then finally, we've got the integral test, the ratio test, and the root test. Personally, if I saw something that was a factorial, I would probably go for the ratio test, okay, versus anything else. That's what I would probably use. If I saw an n power, I would probably use the root test. If it was especially something ugly like we just saw in some of these, okay? So that's there to help you. So what we're going to do is we're going to kind of recap what we have done, okay? So you've studied Unit 10, or we've studied about 10 different tests, okay, 8 of which are actually going to be on the AP test. If you understand p-series and you understand geometric and you understand alternating, you're probably going to be okay. All right, that's enough to get you to pass, okay? So I wouldn't be super concerned about, if you've got those 3, you're probably in really good shape, okay? That doesn't mean that one of the other ones wouldn't be there, but you're in really good shape. Remember, we have to get a 40% to pass, okay? So keep that in mind. You guys have a lot of stuff, okay, this year, because we've got the AB stuff plus the BC stuff. So, so we're determining convergence for divergence for a series. Telescoping root tests aren't going to appear, so we're going to use the following guidelines. So this is kind of like my flow chart, all right? So these are the things we're going to kind of ask ourselves. Does the nth term approach 0? If not, the series diverges. Is the series one of the special types, geometric, p, telescoping, alternating? Can the integral test, ratio test, or root test be applied? And then can the series be compared favorably? So this line of questioning is putting the root test and the ratio test and integral before the BCSD and the limit comparison test. Okay. So let's look at trying a few of these. Okay. So the first thing I'm going to do is I'm going to see if the limit equals 0. So we're going to go so I'm looking, so if I'm going to try to see if the limit is equal to 0 or doesn't equal to 0, I know that it'll diverge by nth term. So that's the very first thing I'm going to try. So limit as n approaches infinity of n plus 1 over 3n plus 1. So when I put that in there, if we're going to infinity, or actually, what's the limit of that? Can you guys tell me what's the limit of that? You guys know, because you just told me in the last one. All right, it is 1/3, which does not equal 0, right? And if I'm looking at my, where's my little, this guy here? I should just copy and paste it over. So if I am looking at this, if it doesn't equal 0, right, it diverges by nth term. So I'm going to use, that's the nth term test, it just diverged. So therefore, this one diverges by nth term test. Okay, done. Okay, now just because I see an n in the power doesn't mean I'm going to go off and do my root test. I'm going to try something else first. Okay, so what kind of a series do we think B is? Can you guys tell me in the chat, what do you think? Remember, go through this line of questioning. If it doesn't equal 0, what's my next choice? What do you guys think? Casey thinks geometric. What does everybody else think? Do we have an R? Do we have a P? Nate's saying to do geometric or ratio. Madison's saying geometric. The two easiest are P and geometric, right? So that's where we want to go first if we can. Okay, nth term's not so bad, but those two are our super easy ones, so that's where we're going to go first. I agree that it is geometric. Can you guys tell me what the R value is? All right, perfect. Pi over 6, which is between 0 and 1. So if it's between 0 and 1, and again, this is where I go back to my handy chart here. I am metric. I am between 0 and 1. Does it converge or diverge? What can you guys tell me? Converge or diverge? All right, good. It converges. So we would say, therefore, it converges by the geometric series test. All right, I would probably rewrite this one that I've got here. Okay, I don't like that negative exponent. It doesn't help me out. So before I even try to figure out which type it is, I'm going to rewrite it as n over e to the n squared. Okay. It doesn't look like it fits a pattern, right? If I tried to do the nth term test, I'm going to get like infinity over infinity, so that doesn't work so good. It's definitely not geometric. It's definitely not p-series, okay? I'm going to avoid the integral test at all costs. Did anybody have an idea of what we should do on this one? What kind of test do you think I should try to run? And any idea is a good idea. We don't need to worry about it being right or wrong. So what is our idea? Okay, Anna's liking the ratio test. Anybody else like the ratio test? Nate's saying maybe ratio test. It's got that kind of weird exponent thing going on that the ratio test did. It doesn't have a factorial. If it has a factorial, I'm going to definitely go. Oh, you mixed up the notes. That's okay. That's okay, Nate. Root would have worked on that one too, but we're always going to pick a geometric over a root. Okay. All right, so let's try the ratio test on it. Why not? So let's go the limit as n approaches infinity. You know you have to plug in the n plus 1. So it's going to be n plus 1 over e to the n plus 1 squared times, and I'm going to flip the reciprocal, e to the n squared over n. Okay, let's see what we can do to simplify this guy a little bit. Well, it looks like, I'm looking at the answer key right now. What did they do? They somehow took out the plus 1. All right, if I am looking at this piece, I don't see those canceling like they're canceling them in my notes. If I look at this piece and this piece, isn't the limit going to be 1? Okay, so I can see, hey, though that limit looks like it's 1 to me. Okay, so I'm going to get rid of those because they're basically going to make it 1. It's not going to have any difference on what's there. Okay, so that means I've got the limit as n approaches infinity of e to the n squared, and then I'm going to go ahead and FOIL this guy out. So that when I FOIL, I'm FOILing n plus 1 times n plus 1. And this looks a little bit weirder than what we saw in the actual ratio part of the lesson. So n squared plus 2n plus 1. All right, and then remember when we are dividing, what can we do with our exponents when we're dividing? What do you guys remember from algebra? What do I do with my exponents when I'm dividing? Oh, we're going to subtract the exponents. Cool. Or can I rewrite it like this? Limit as n approaches infinity of e to the n squared over e to the n squared times e to the 2 plus n. I was doing that in the lesson, wasn't I? So we could do it either way. So either I subtract the exponents, or I can rewrite it like this, and either way, those guys cancel. I'm left with a 1 in the numerator, and I have the limit as n approaches infinity of 1 over e to the 2n plus 1, which when I plug in, I get 1 over e to the infinity, which equals what? What does it equal? All right, it definitely equals 0. Okay, so going back to my ratio test, when I am less than 1, am I going to converge or diverge? So am I going to converge or diverge, guys? Converge or diverge? Nate says converge. Casey says converge. All right, so we're going to, so therefore it converges by the ratio test. So therefore converges by ratio test. Perfect. Okay, let's look at this guy right here. Okay, I'm going to get a totally different color so we can see the work. So I'm looking at D. Definitely doesn't look like, if I tried nth term on it, I'm not getting that it's not equal to 0, right? So I'm not going to do nth term on it. Let's see, because if I put that in there, it would be, yeah, it would be equal to 0. So I can't, it would be, so the nth term doesn't work, okay? I can't do p-series. I can't do geometric on that one, right? So what do you think we're going to use on that one? Anybody got an idea? What do you think? Could I do a comparison test? And it doesn't really matter which one I do, okay? Nate's like, sure, let's do that, okay? It doesn't matter which one I do. Can I help you? What? You only have 20 minutes left. You have to be back in class. You should eat some lunch. Find something to eat. Okay? All right. You're out early, LA Bells? Yeah. Okay. Oh, okay. That sounds like fun. All right. Ellie's mean teachers assigned her a bunch of homework. You have a mean teacher too, don't you, that assigns you a bunch of homework? Mrs. Ballard's that way too. She just said her math teacher is the queen of assigning the most homework. So I think that's just math teachers. Okay. Hey, Andy, get whatever you need out of the fridge and close it. All right, so let's do a limit comparison test. Okay, so I'm going to do a limit comparison test. Okay. So, and of course, I'm not spelling the whole word, am I? All right, so I need to figure out what to compare it to. I'm kind of liking this 1 over n business, right? Because I know what that is. I know that that's the harmonic series. So I'm going to compare to that. Compare to the sum as n equals 1 to infinity of 1 over n. And that means it's a p series equal to 1, right? So does that one converge or diverge? Tell me what you think. Converge or diverge? You can go back and look at the chart, right? You can go back and look at your orange sheet or that chart there. Either one works. So is it converge or diverge? You're looking right in here. What do we think? 1 over n, converge or diverge? Okay, Josue's saying diverge. Do we agree with him? Casey's saying diverge. She agrees. Okay, everybody's diverge. Awesome. So we're going to say that that diverges. So I'm going to do the limit comparison test. So remember, this is where we do we plop the original over the comparison, right? Or I flip the comparison. So we've got the limit as n approaches infinity, the absolute value of the original series divided by the comparison series, or we flip and multiply the comparison series, which really means I have the limit as n approaches infinity of n over 3n plus 1, which, what's the limit of that one, you guys? Tell me in the chat. You guys have done this one a couple of times, the same kind of limit. What do you think the limit is of that one? All right, I'm agreeing with 1/3. Okay, so since these guys were, let's go back and look at the what it said. Ooh, not that one, this one. I had too much open. All right, so limit comparison says if L is greater than 0, then they both converge or both diverge. So since we were greater, the limit was greater than 0, we are both going to diverge on this one. So therefore, diverges by the limit comparison test. Give you a minute to write that down. I don't know what you're pointing at. The counter? How old was that? I don't know. When did we have pizza? Is that even the previous pizza? Or was that 2 pizzas ago? Okay, I don't know. All right. It's that they're trying to find lunch that hasn't been in the refrigerator too long. Don't you hate that? Okay. Let's look at, do you notice how quiet it is today other than the 2 big kids? The little guys aren't here. It's kind of interesting today. It's different. Okay, so I hope let's see what we remember from last week. We have this guy here. What kind of series test are we going to do? Tell me in the chat. What do you think? What do you guys think? When I have, yeah, there we go. Casey's saying alternating. Do we agree with her? Okay, Josue says yes. Okay, so let's do an alternating series test on this one. So the very first step is deciding if the limit as n approaches infinity of the series equals 0. So I'm trying to decide that first. So I'm seeing 3 over 4 times infinity plus 1, which definitely equals 0. So phase 1 complete, right? Okay, so that's Nate. That's why we need to, you need to get this done, right? You haven't done it yet, you need to get it done, all right? And in theory, could you print that thing? You could, okay? It's probably better if it's in your own handwriting, okay? Because you're gonna help, you wanna start, that's the way you start remembering it, right? So I would say get your orange sheet written out, or if you didn't go pick it up, get a piece of paper that's brightly colored if you can, and write it on there, okay? Dig into mom's craft supplies, right? So her, whatever colored paper she has, you could even put it on cardstock, right? And make it pretty on cardstock. And then it would feel different and you grab it really fast, okay? All right, so phase 1's complete. Phase 2 is that we have to determine if the terms are decreasing. So let's just try to substitute in, okay? And see if I get decreasing terms. Remember, we're ignoring the negative because that's the negative is just going to alternate the signs. So let's see, if I put in a 1, I get 3 over, see, 4 plus 1 is 5. Then I would get 3 over 4 times 2 is 8 plus 1 is 9. So that's like 1/3. 3 over, or let's see, 4 times 3 is 12 plus 1 is 13. It looks like we're getting smaller, right? If I go one more, 16 plus 1 is 17. I'm definitely know that I am getting smaller, okay? So therefore, and remember, I can only tell convergence by the alternating series test. So therefore, it converges by, and this one you're allowed to abbreviate, alternating series test. In your notes, though, you might want to actually write it out. All right. What do you guys think on F? What kind of series is F? What kind of test should I do? Let me put that screen back up there. I'll put that back up there. Which test should I do? For n factorial over 10 to the n. Okay, Anna's saying ratio. That's the one we just learned, right? Like I'm looking at the notes on this one, my answer key, and they did it by nth term. But that doesn't mean we have to do it by nth term. I see a factorial and my brain goes right to ratio test. Okay, so let's try it by the ratio test and see what happens. Let's see if Mrs. Ballard can do the ratio test from memory, okay? So we know for the ratio test that we have to plug in n plus 1, right? So the limit as n approaches infinity of n plus 1 factorial over 10 to the n plus 1, and then we divide by the original, or would we multiply by its reciprocal? Okay, now I am going to try to cancel stuff. So I've got n plus 1, and then the next one would be n factorial. This guy can break up in 10 to the n and 10 to the first, because I'm undoing the property multiply and we add our exponents, times 10 to the n over n factorial. All right, we get to do the fun part where we cancel some stuff, right? So n factorials are canceled, 10 to the n is canceled. So we are left with the limit as n approaches infinity of n plus 1 over 10. Ooh, interesting. When I plug this in, I get infinity over 10. So what's that going to equal? What's that going to equal? Yeah, it's going to equal infinity, right? Okay, so I don't know if we remember if we saw this or not in the ratio lesson. So let's go back and look at our chart here. So if I am equal to infinity, look, I diverge. So I'm diverging right now in that one. So therefore, diverges by the ratio test. Now, we got a choice here. What if it was multiple choice or multiple response? And they said, hey, maybe it diverges by the ratio test and the nth term test. Because remember the AP test, you know how like they do those ones where it's like, which one of these are true, right? This is one where they could set up like that. That's how they do multiple response, right? They could say diverges by nth term, and then by ratio, and then maybe by maybe it converges by something else, right? And you have to decide which ones are true and which ones are false. And now it's not writing converges by, I don't know, root. Okay, they have one big root on the test, but that's kind of the idea behind the question is something like that. Okay. All right. Let's look at G. So what test do you think we should do on G? What would be the easiest based on what we just learned, even if it's not on the AP test? What do you guys think? Yeah, that looks like a root test, right? And I'm looking at the answers, and they did a limit comparison with a geometric series. Okay, so we could do it more than one way. Remember, if it's on free response, even if it isn't officially part of the curriculum, you can use it if it's good calculus. Okay, so there's a couple of different ways. Like on volume, I don't teach you the shell method. You could do stuff by the shell method. Okay, if you know what that is. You don't have to know what that is to pass. Okay, so I'm going to go ahead and use the root test on this. So we've got the limit as n approaches infinity of the nth root of the absolute value of n plus 1 over 2n plus 1 to the n. You guys told me early on that these guys cancel. So we've got the limit as n approaches infinity of n plus 1 over 2n plus 1. What's the limit equal to? One more time. We're getting good at this one, right? We're reviewing all that AB calculus today because this was the AB stuff that you won't see other than in this context, okay? All right, I'm seeing 1/2. Let's go back to my root test guy here. Let's see, root test says that when it's less than 1, does it converge or diverge? Can you guys help me out with that in the chat? Converge or diverge? What do you think? And technically converge is what? Nate's saying converges, so therefore converges. And technically we're supposed to say the word absolutely. And again, we will see that pop into Wednesday. Converges absolutely by the root test. Okay. We will